Hello students, today we'll see an important topic called moment of inertia. Moment of inertia. I will clear all your doubts regarding moment of inertia. What exactly is the moment of inertia? So at first, let's see what the meaning of the term inertia is. Inertia in general terms refers to mass. Okay, inertia in general terms we can say it is mass. We can say it is the thing which resists the force to act. Okay, whenever we apply force to some object, then that object tend to oppose the motion. Okay, they don't want to move from one place to another. They tend to oppose the external force, and that property of that object is called inertia. Okay, so imagine two persons, or we can say two objects. These are two objects. One is the heavier one, one is the lighter one. In this case, the heavier one will have more inertia. If this mass is m1, this mass is m2. If mass m1 is greater than m2 is greater than m2, then in this case we can say m1 is having more inertia. Okay, okay. It's given that the frictional force between these two, the surface and the mass are same. So if the frictional forces are same, greater is the mass, greater will be the inertia. So I think the concept regarding inertia is clear. Now let's see what is moment of inertia. See, in case of moment of inertia, the things are not like the mass, the heavier the mass, the greater will be the moment of inertia. It's something else. Like imagine two discs. Imagine two discs are there. Consider both the discs are having mass m1, like both the discs are having same mass, m1 is the mass of each disc. Then in order to rotate the disc, some sort of torque is required. So let the torque applied in this case is tau 1. Let the torque applied in this case is tau 1. So we are rotating the disc about an axis which is passing from center. Again, the axis is passing from center. Okay, and in the other case the axis is not passing from center, it is passing from the side which is away from the center. In this case, that the torque acting on it is tau 2. Okay, so you will experience that tau 2 will be greater than tau 1. Okay, torque in this case will be greater. You can do this thing at your home also. Take the book you have, any book, and try to rotate that book about an axis. Like if this is your book, then try to rotate about an axis which is passing through the center of the book, like this. Okay, try to rotate the book like this, and then hold the book at the end. Okay, hold the book at the end, and again try to rotate like this. Okay, so you will feel that when the axis is away from the center, you will have to exert more torque, or we can say you have to exert more force to rotate this object. This object will resist more in case if the axis is away from the center of mass. So when the axis is away from the center of mass, then the torque required is greater. So even if the mass are equal in case of linear motion, see if you want to displace your notebook that you have just used, in any case the force required will be equal, but in order to rotate it depends on where the axis of rotation is. If the axis of rotation is passing from the center, it is easier. See again, if the axis of the rotation is passing from the center, then it is very easy to rotate, but if the axis is not passing from the center, it becomes tough. We can say the moment, or we can say the inertia in case for rotational motion increases, and that inertia in case of rotational motion is nothing but moment of inertia. So moment of inertia at first depends on the distance from the axis of rotation. And second thing, see, imagine a book. Again, take your book, like this is your book. Okay, try to rotate the book about the axis passing from center. Now take a thicker one. Okay, now take a thick book. Thick book, I mean to say its mass is greater than the previous one. So this is the thin book which is having less mass, this is the thicker one. Both the this area, surface areas are should be same. So now try to rotate about this axis. If you try to rotate about this axis, in that case you will feel even if the axis of rotations are passing from the center, in this case more torque is required, greater energy is required to rotate this thing. So we can say in this case inertia is greater. So again, moment of inertia depends on two things. See, if you are rotating your book about an axis which is passing from the edge, okay, more torque is required. And again, if the object is heavier, the more torque is required. So the moment of inertia is a combination of two things. Moment of inertia is combination of two things. Number one, it depends on distance of the axis from center of mass. Cm means center of mass, and also it depends on the mass of object. See, if you are rotating that thick book, then in that thick book the greater energy was required. So it depends on mass of the object also. In case of linear motion, it was dependent only on mass. So in case of linear motion, mass was all about inertia. But in case of rotational motion, moment of inertia is a combination of two things. One is distance from the axis of center of mass and mass of the object. So therefore the formula becomes I is equal to mk square. I is equal to mk square, where m is called mass of the object and k is called radius of gyration. Radius of gyration. Radius of gyration is a sort of average radius. See, if you are rotating book like this, then the radius of all these particles are not same. See, radius means when the object is rotating, all these particles will traverse a circular path. All these particles will traverse a circular path, and those radius of all the circular paths will not be equal. So in order to find out, we have to take a physical quantity called radius of gyration, which is given by the formula k is equal to root of r1 square plus r2 square up to rn square by n. So this is a sort of average radius. You are not supposed to find out this thing like in this way. You must be given like 2 or 3 masses like m1, m2 and m3, and their positions will be given. You have to take r1 square plus r2 square up to r3 or r4 square by 4 or 3, whatever the case may be. So this was all about moment of inertia. Okay, the unit of moment of inertia is kg meter square. Its unit is kg into meter square. Its dimensional formula will be m1 L2. Okay, so that was all about moment of inertia.